Yep, notes. Our title is SOHCAHTOA, in brackets if you want, right angled trig. And this forms quite a large part of our next topic. Have you seen that acronym SOHCAHTOA before?
Yes.
Good. And you all memorize exactly what it means? Good.
And then it's like opposite, adjacent, and then hypotenuse. Yes.
Alright. So that's our next line. And all the way into second year uni, when I got into an exam, I'd write that at the top of the page, the first thing I'd write, just to remind myself. Because it's something you really need to remember. So sine theta, it's on freeze. No, it's not. Sine theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse. And tan theta is equal to opposite over adjacent. Alright? And the important thing is clearly the letters. Alright, now memorising that isn't much use to us unless we know how to apply it to triangles. And today is very simply applying it to triangles, and with SOHCAHTOA questions you generally get one of two sorts of questions. So remember in Pythagoras, either the unknown was on the hypotenuse or it wasn't. In trig, they either wanted you to find an angle or a side. And today we learn how to find an angle and a side. First step, draw the triangle and label it. Can you guys please draw two right angled triangles? Alright, when we have our triangles, one is always very easy to label. One side is always the hypotenuse, and it's always directly opposite the right angle. However, others take a little more thought, the other two. So with Pythagoras, it didn't matter which of the other two sides we labelled, A and B. Here it does matter. We can't just label opposite and adjacent randomly. We have to think about the angle we're either given or finding, and the opposite and adjacent occur in relation to that. So basically the hypotenuse is always opposite the right angle. Then look at the angle. Whichever side is next to the angle or adjacent to that angle becomes the adjacent. Whichever side is opposite it, so directly opposite like this, becomes the opposite. Alright. Now, these sides change if the angle we're talking about changes. So if our angle appears up there, this side becomes the adjacent, this side becomes the opposite. And the first step to any right angle trig questions is label the sides. Once you've got SOHCAHTOA, label the sides, because then that will tell us which side to use, which trig identity to use. Everyone got that? Beautiful. Two sorts of questions: finding an angle and finding a side. And then please draw two other right angle triangles. Alright, Jack, can you give us a number? Another one. Good one. Alright, finding an angle. If we're finding an angle, then we need to have found two sides, or be given two sides. Alright, so we've got two sides. Our first step, label. We have the hypotenuse, we have the opposite, and adjacent. Now, the question is, which one of SOHCAHTOA do we use? And we answer that by looking at the sides we know. So we know the opposite and we know the hypotenuse, so we know O and H. We can look up to SOHCAHTOA and see that the one with O and H here is sine. Okay? So we label all the sides, see which ones we know, and that will tell us which identity to use. And then we write the identity, that sine theta equals opposite over hypotenuse, and then we substitute in values. Sine theta equals the opposite is 15 over the hypotenuse of 34. Now, do you know how we get sine on its theta on its own from there? Yeah, inverse sine. What some people do here is they divide both sides by sine, which doesn't make sense because sine isn't an unknown. It's not like an a or an x that you can divide it across. It's called a function. So to undo a function, we have to have an inverse function. And fortunately for us, an inverse function is simply a button on our calculator. So theta is equal to the inverse sine, which is just written as sine to the minus 1 of everything in that fraction, 15 over 34. And most of you will find inverse sine in your calculator by doing shift sine. Alright, so shift sine, open your brackets, 15 divided by 34, close brackets, and that will find you your sine. Your theta. Does anyone get a strange answer? Did anyone get 0.45? No, that wasn't what you meant to get, but it is a possibility. Yeah. If your calculator is in a setting called radians, so you know how we use, for example, both feet and miles and yards and meters and centimeters to measure to measure length. So we can measure a length in a foot or 30 centimeters. We measure angles two different ways. Up until now, you've been measuring them with degrees, but in later maths, further maths, you measure it with radians. If your calculator is in radians, it will come out as 0.45. But if not, what was your answer? 26.18. If yours is on 0.45, hit shift setup, Nikki. The menu button. Shift menu. Scroll down and you'll see rad. It's rad, yeah. You do. Down you go angle. Yeah, okay, angle. And then next to angle will be rad. Yeah, you want to read degree. Click F1. And then re-enter that sum and it'll come out in the correct one. Okay? Alright, so finding an angle, you label the sides, you identify the trig identity you want to use, in our case sine, write it out as sine theta equals opposite over hypotenuse, substitute in the numbers, and then inverse sine to find the actual thing. Okay? Right, other side, other one, finding a side. Gabby, give us a number. 15? Tyler, give us another. Lovely. Alright, first step, label the sides. Hypotenuse, opposite, because it's opposite the angle, and adjacent because it's next to the angle. Alright, so we have O and an A. We look up the top for SOHCAHTOA and notice that this one here has an O and an A, so we're using tan. Tan equals opposite over adjacent. Down we go. Tan equals opposite over adjacent. Then substitute numbers in, and sorry, tan theta. Tan 27 equals opposite, which is 15, over adjacent, which is x. 15 over x. X is the unknown. And now we want to rearrange to solve for x. And we can do that in a couple of steps, but the easiest way to remember it is if you decide for something looking like that, the tan 27 and the x swap places. So what's going to happen eventually is you'll have x equals 15 over tan 27. The intermediate step is you're multiplying both sides by x, so you get x tan 27 equals 15, and then you divide both sides by tan 27 and you end up down here. Right. But essentially if you see this, the x and tan 27 can just swap. You alright? Stay with us. And then if you put in your calculator 15 divided by tan 27, you will get the output, the answer. Beautiful. X equals 29.43 or 44 meters.
You can do it over like a fraction. You do have to fraction.
That's right, divide will work for you then. Alright, now on Tuesday next week we will be continuing SOHCAHTOA a few more things, but I also want to do quite a lot of talking, I'm afraid, on Tuesday because I won't see you Wednesday or Friday. On Friday you'll be given the lesson to work on folios. Thursday will be largely SOHCAHTOA but some other things as well, and I'll teach you via YouTube. Sorry, I'm on a conference. Enjoy.
Do you know that?
Huh?
Do you know what teacher will have?
No
Do
idea.
you know what teacher will have next semester?
No idea. No.
You guys have like 2 separate teachers.
Alright, I'll stop recording.